Le Chatelier's principle states that if a system in equilibrium undergoes a change of conditions, it will move to a new position in order to counter the effect that disturbed it and regain equilibrium state again. There are three different stresses that could affect the equation. Changes in concentration, that could be the solid or the solvent, changes in the pressure, and changes in temperature. For explaining the concentration stress, we could see a reversible reaction example. First we have A plus B, and we produce C and D. When you have more A and B, the system will manage the products and the reactives to make the system in equilibrium again. And in this case, the equilibrium will shift to the left. And when you are more C and D, the equilibrium will shift to the right. When concentration increases, the equilibrium will shift to the opposite right of the reaction. And when concentration decreases, the equilibrium will shift to the same way of the reaction. With pressure, we have to remember that it's only in gases. When you are increasing pressure, you have less volume, so less space. Going back to our example, the equilibrium will shift to the right, and when there is less pressure, will shift to the left. Because equilibrium will shift to the side of the reaction with fewer moles. So more pressure will favor the side with less moles, and less pressure will favor the side with more moles. In changes in temperature, you have to consider the energetics. If the forward reaction is endothermic, then the reversible reaction will be exothermic. Here we have the same hypothetical reaction where A plus B reacts to form C plus D, but here we have a changing of temperature. In forward reaction, the temperature is released, and in reverse reaction, the temperature is absorbed. So if we increase the temperature, endothermic reaction will be favored, and if we increase the temperature, exothermic reaction will be favored. Here, catalyst is so important because it speeds the reaction. So we have to know more temperature favors endothermic reaction, less temperature favors exothermic reaction, and the catalyst doesn't affect the equilibrium.